Question 2. In the diagram below, angle C1 is equals to 85 degrees and angle AEF is equals to 175 degrees. So we are told here that angle C1 which is this here is equals to 85 degrees. So I can write this down here to say it is 85. And we are also told that angle AEF, which is going to be this angle here, is 175. You must also notice that this angle here, C1 and C2, is actually 90 degrees. The whole of this here is 90 degrees. And that already tells us that also C3 has to be 90 degrees because, you can't have 90 here and this side is something else if, this is a straight line. Now, we can then look at 2.1 that says to us, show that line AB is actually parallel to line CD. So we need to prove that these two lines are parallel. Now, there are three ways in which one can prove that lines are parallel. The first way is to prove that the corresponding angles are equal. The second way is to prove that the co-interior angles are supplementary. And the third way is actually to prove that the alternate angles are equal. So basically, you look for an F shape, a U shape, or a Z shape. Any of those ways will assist. Now, when I look at this diagram, I can see that I have a Z shape here. And on this Z shape, it means I have to prove that this angle here, which is angle AEC, is actually the same as angle C2. If I'm able to prove that these two angles are the same, then I can be able to say that these two lines are parallel. AB is parallel to CD. Now, in order for me to do that, I will actually say here that I can see that the line here, CF, is a straight line. So that means, and I can see that we have a line BD that intersects that straight line. So that would mean I have this angle being next to this angle. They're adjacent to each other. So when I add these two lines, they must give me 180 degrees. They must be supplementary because they are actually angles on a straight line. So that's what I'm going to firstly do. So I will firstly say angle AEC, this angle here, angle AEC, this should be angle AEC. The accent should be on the E. If I add this to angle AEF, this one that I'm given, if I add this to AEF, I must actually get 180 degrees, a total of 180 degrees. The reason for that is because these are angles on a straight line. These are angles on a straight line. They must be supplementary. And from here, I will then have angle AEC plus 175 degrees to be equals to 185. I mean, we were told there that this one is 175. Now, at this stage, this question becomes really, really, really boring because, we're just going to solve for AEC. I'm going to take the 175 to the other side so that I have negative 175 when it comes to this side. And I can therefore conclude to say angle AEC is actually equal to, when I subtract 175 from 180, I see here that I'm going to be left with a 5 degrees, because the 100 will fall off. I have 80 minus 75, and that should be a 5 degrees there. Now that means I actually have found this angle to be 5 degrees. Now the next step would be to find this angle really. And to do that, we will say that this whole angle here is 90 degrees. That means I'll say angle C1 plus angle C2. So I'll say here angle C1 plus angle C2 is equals to 90 degrees. How do I know this? Is because I'm given, on this diagram here, we are told that this is 90 degrees. So we are given, that's our reason there. However, we know that angle C1, this one here, is actually 85 degrees. So this is 85 degrees plus angle C2, it should be equals to 90 degrees. So this means here we're going to have angle C2 to be equals to 90 degrees minus the 85 degrees. And obviously you can see that 90 minus 85, it will therefore say that C2 is equals to a 5 degrees. Now look at this. This is really fun. Our angle AEC, this one here, is exactly the same as angle C2. This one here, they are both 5 degrees. It then means that therefore this line here, AB and CD, must be parallel to each other. These two lines must be parallel to each other because they make the same alternating angles. So that's the conclusion we're going to give here, to say therefore line AB must be parallel to line CD. But what is the reason? How do we know that? Well, the reason is because the alternate angles are equal. We have proved that the alternate angles, this and that, are actually the same. They're equals to 5 degrees. Do you find geometry to be fun or to be a fuss?